So that beaker of water that you see right there is room temperature water. It's been sitting out for a little bit, probably somewhere between 65 and 70 degrees is what that water is, okay? I have two little beakers that I'm going to put two different types of liquid in it. So let me go get them, and they are going to represent magma. I've got blue magma, okay, which is water that has been in the refrigerator and is pretty cold. I'm going to put it in this little beaker right here. And in just a minute, I'll use the hot magma, okay? But I'm going to take this blue beaker right here, and I'm going to put it into this container of room temperature water. Make a prediction. What's going to happen to the blue liquid? What do you think? It's going to cool down? What do you think? So the blue is going to go to the top. What do you think? It's just going to float, okay? What do you think? You think the cold will go to the bottom? Let's test this out. I'm going to put a piece of tape over top of it just so that it doesn't all fall out at once. Okay? And I'm actually going to lay it in on the bottom because if you notice, at first, when I put it in, there you go. What's happening? It's coming out and it's going where? Down. In fact, if I tip it, this way you can see it even more. What's the blue doing? Where's it going? It's staying down here on the bottom. Can you see that all along there, the blue is on the bottom? Does everybody see that? Because it is what? How would you describe the temperature? It's colder. And so the particles, if it's colder, are they going to be more dense or less dense? If it's colder, they are more dense. Think of it this way. When you're cold, right, and you're in a huddle, you want to huddle up with people to try to get warmer. That's what the particles do. They're cold. They don't have a lot of energy. They huddle up together. They are more dense. Okay, now I'm going to take the hotter magma that exploded. Who can make a prediction? What do you think is going to happen to the hot magma? What do you think? It'll float? Anybody have a different idea? What do you think? It'll go straight up to the top? Is that what you said? Oh, it'll push the blue to the top. Okay, let's test it out. I'm going to put a piece of tape over it. I'm going to stick it down in and immediately notice what happens. Take a look. It's not even sinking. It's going straight where? Up. It's going straight up to the top. So you can see there's still the blue on the bottom down here, and there's still then the red that's up top here. Now, after a while, what's going to happen to the temperature of this red water? Is it going to increase or decrease? It's going to decrease. What's going to happen then to the water? Is it going to stay up there or is it going to eventually sink? It's going to sink. What's going to happen to the temperature of the blue water? Is it going to stay cold forever? No, it's going to heat up again. It's going to go back to room temperature. And then what's going to happen to it? Is it going to stay on the bottom or is it going to rise? It's going to rise. So you can see a circular pattern that starts to happen. Does everybody see that? Okay. Now, eventually this water is going to be what color? Purple. It's going to be purple because the red up here and the blue down here are all going to mix. But what if I had a heat source down deep underneath of this beaker that would cause any water that's down here to heat up? Then that convection current would continue. What's the heat source inside the earth? The core. The core continues to heat up magma, so it rises. When it gets to the surface, what happens to the temperature? It cools, so it goes back where? Down. That's a convection current.